All right, good morning, guys. Excited about the lab, right? A lot of exciting things going on. And this is our TA, Mohammed. He'll be around to help you guys to debug your circuits. And let me, since I already talked about the lab yesterday briefly, I still want to, introduce you the board. So everybody is going to take a bag which has a microcontroller, a programmer. Let me just show it under the camera. That will be easier. Everyone can see it. Okay. Okay, and this is also recorded. I'm gonna upload the video to the website after this this lecture. Okay. So a bag like this has a programmer. And if you have been using Arduinos, you don't have a programmer because it has a little chip on the board already, but this one does have a programmer. And this one is the microcontroller itself. Okay. I have two cables. The USB mini cable is a little bit bigger port. This is macro. You can see it's smaller than the mini one. So this one connects to the. You'll figure out because the other one doesn't fit. So the two cables for two different boards to program your circuit. And you also have jumping cables, the jump wires. What are jump wires? They're just making connections on the board, right? And these are they are all female to female connectors because Dr. Kelston has the board designed as male headers on the board. So if you want to make the connection between two headers, you have to use the female to female jumping wire to make the connection. Makes sense, right? And in addition to that, you also have little jumpers. It's a little bit confusing. There are different names, but doing the same thing, just making connections. Jumping wires can make the connection from a relatively longer distance, from the one side of the board to the other side of the board. However, the jumpers, these are the little jumpers. It's just a metal piece in the middle, okay? So if you plug in with two adjacent male header pins, it's gonna make a connection in between these two headers. It's making a short circuit. So the nice part of this one is after you close the circuit with the two pins, sometimes you wanna probe it. You know what I mean? You connect it, but eventually you wanna see what the signal is going into the pin or coming out from the pin. It's already closed or being enclosed into that little jumper. What can I do? Did you see there's a little metal wire on the top is exposed? It's not being entirely sealed into it. So you can always use a clipper of the probe. Let me show you. There are so many mistakes students are making when they're doing their first embedded labs. It's happening a lot. One of this will happen, with you guys. All right. I assume you guys are familiar with the cables, right? So what is this cable used for? And what is this cable used for? And why? Okay, so see this cable? Usually there will be a little screw inside. It's used to adjust the little capacitor with a probe. It's called a compensated probe. Compensated probe. It has a little capacitor, adjustable capacitor inside. But the other one doesn't. The other one doesn't have a screw over here. Just a regular BNC cable. And if you look at the connectors, there are just the two alligator connectors. Like alligator, right? Alligator connectors. So which one should be used for the probe and which one should be used for the function generator? Let me know. I know mistakes is gonna happen since I have taught electronics classes for like 8 years. I know it's very common mistakes to make. So see this combination here. This one doesn't have a screw and alligators, and this one has a screw and it's a probe like this, a long probe and a ground pin here. So this is for the probe, for the oscilloscope. Okay, this is for the oscilloscope. And this is for the function generator. And this one is not attenuated. I can take the time to talk about that later, but you should know that this is attenuated because it's 10 to 1. If you look at the, oh, it's adjustable. See here? If you move to 1x, it will be 1 to 1, which means whatever you are probing will be directly sent to here, to the oscilloscope without attenuation. It's important. A lot of teachers don't teach that. So usually we don't use one versus one or one-time attenuation or no attenuation because it slows down your probe. You know, it's all the circuits, especially when you are probing high frequency signals, they oscillating super fast, which means it's charging and discharging caps really fast. If you attenuate it, what's happening is whenever the signal receives the probe, it's getting divided by 10 times. But you're asking, why do we have to divide the signal by 10 times? And are we still measuring the correct value? You are probing it, you want to see the correct value, but you are dividing by 10 times. Why? First, we want to make our probe to be more capable of probing faster signal. That makes sense, right? Because we are reducing the voltage from, for example, 10 volts to just 1 volt. So it's going to oscillate from 0 to 1 at like 100 megahertz. It's way easier than from 0 to 5 volts running at 1 megahertz. You know, it's charging and discharging the same cap to a very large magnitude of voltage. It's way more difficult compared to like just a 1 volt oscillation. So smaller voltages is easier to drive, just to let you guys know, okay? That's a conclusion. So that's why we attenuate it by 10 times. You want to switch it to 10, okay, switch it to 10. Make sure if somebody switched to 1x, move it back to 10. That's the first thing you want to look at before you use the probe. That's exactly the first thing you want to look at. All right, make sure it's 10x. Okay, and the second thing, usually you connect this one, the connector to the probe, right? So to the input of the probe of the oscilloscope, and this one to the calibration signal of the oscilloscope, the one I have or back in Durango. I mean, I believe most of the oscilloscope have the same functionality. So connect to a standard pulse. It's usually 1 kHz with 5 volts. It's a standard waveform, not getting distorted or anything. Just standard, strong, solid digital signal, 1 kHz, 5 volts oscillation. You probe to that signal on the oscilloscope, and send it to the input. If you see some overshooting or some undershooting signals, it's not really clean and solid waveform, square wave, you need to adjust the screw over here a little bit, use a screwdriver. If you don't find a screwdriver, you know, search in the lab, see if you have a screwdriver somewhere else. Otherwise, you're not getting correct signal wherever you probe. It's going to be distorted. So 2 steps, okay, 2 steps. We'll probably be on the quiz sometime. What's the first step? There are another step. I'm going to tell that first. So you have 10x, right? Check the 10x, do the calibration. So the third step is you do the connection, right, to the calibration signal input, and look at the channel. There's a probe ratio, so they have to match. So what's really happening is you put a 10x here, and you tell the oscilloscope to fix the signal to the correct value. You are probing like 10 times less, right? And you want to probe to display a correct value. Just tell the oscilloscope times 10 for the display. But actually, all the voltages getting into the oscilloscope is actually 10 times smaller. However, it fakes it to a correct value by times 10 and displaying the correct numbers. You know what I mean? So that's how you use attenuated probes or compensated probes. So 3 steps. First step, check here. Which X you want to use? 10x. Okay. Second step, calibration. You don't have to don't have to do it every time, because I don't believe people are coming here every week to you know, mess with the screw here. If you calibrate once for the rest of the semester, most likely you are getting a good probe. You don't have to do it every time. However, it should be the second step you have to do today. So, and I have to figure out where the standard signal is on your oscilloscope over here. It should have one, okay? And the third step is check the probe's setting. see if it's a 10:1 ratio. If you can turn on that oscilloscope, I can show you guys how to do it right here, and so you guys can come over and take a look at it really quick. I don't have a video recorder. I should, but is it on? There must be. Okay. Cool. Okay. All right. My experience is if I use some tutorials like this, have all the snapshots and all the steps, step by step listed on the website, students can just follow and get everything done. So I'm not worrying about that. I don't think I have to lecture every single step for you guys because it's super clear already. I just follow. If you couldn't, for example, get the software downloaded, you can always ask me or the TA and see if we can help you. And the connection is easy, right? But there are some issues. It's not super stable for the connection. So I probably went through 9 of the labs in the summer just to prepare for this. And the connection between these two boards is not really stable. A lot of times you will hear a beep, and it's just checking out from the computer. It's not. You just have to reboot it and reconnect it to make sure the programmer shows up in your EDA tool. It's a little bit frustrating, but not a huge problem. It's gonna work out fine. Not as easy as Arduino's, but it works. Okay. I'm not seeing any issues with all these steps. No problems. Oscilloscopes. If you don't know how to use it, raise your hand. I'm gonna show you how to use it. But you must use the correct probe. I just told you guys which probe to use. I've seen so many students use this one for the oscilloscope. Never do that, all right? Never do that. This is not an oscilloscope probe. It's a function generator probe. A cable, not even a probe. It's a cable. It's outputting signal. The magnet, there's a whole effect experiment. You have to use a magnet. I don't know if you have a magnet in a lab, but you know the speaker has a magnet. I was not trying to encourage students to do it, but for today I think we can. So the speaker is one of the components for the labs, and I can use this one for the magnet temporarily, but make sure. The reason I don't want to use it for the experiment, for the whole effect experiment, is it's a metal cover, so when you move it very close, I think the chip is over here probably. I forgot. I will follow the tutorial and find it. But when you move it closer, it's very likely you'll touch the header pins on the board and make a short circuit. You know what I mean? So never touch it. If you have to use this one as a magnet to give a signal to the magnet sensor, a magnetic field sensor on the board. Just never touch the metal from the speaker to the pins and make a short circuit. Just don't do that. Anything else? Oh, you have to collect the signals through the serial port. It's already programmed, and collect them and put in an Excel sheet and plot it. Okay. And this teaches you how to use a jumper. I already told you guys the jumper. See the little metal wire here that you can probe. Use a little clip of the probe. Okay. This is how to display 2 signals on the oscilloscope at the same time. And this is the demo task. So definitely run that demo task with the TA, either today, the best case is today, otherwise for the following days of the week. Other things, other experiments are all snapshots or YouTube videos according to the description or rubric over here at the bottom of the page. Okay? How many of you have a lot of experience with the oscilloscope and you know how to use it immediately? If I give you a probe, you know how to adjust the ratio, the calibration, the display of 2 channels. That's a very fundamental operation. 2 channels, magnitude, timing, adjusting, probe ratio. attenuation ratio. So there are 2 students over there, so you guys can do it, you think? Who else? There's no way that I can show the little monitor to 25 students. So I'm gonna let you guys help out. Anyone else? You? No? Okay, so we are going to have 2 stations. You can turn this on. You got a question to ask us. Okay. Turn this on. And grab a probe and make sure it's 2x and settings. Show the 2 signals display. Maybe I just So people here probably come to this station. So I'm just going to show you guys how to use it. And I'm going to show the rest of the people over there. You can use your phone to record it if you want. You can record a short video over here when he's working on it.
Excellent.